Hi, this is Brock here. I just wanted to talk to you a little bit about this standard deviation portion that's at the bottom of this page. We don't need to know this specifically for the course content, but it is worth discussing simply because we are talking about stats. It does look a little bit daunting, but and what I mean by daunting is a little bit scary looking, a little bit confusing. So the standard deviation is simply how far or how dispersed the data is from the mean, and the mean is the expected value. It's denoted by the symbol sigma. If you'll look right here, this is sigma. It's actually a lowercase sigma for the Greek letter. This symbol right here, ironically enough, is capital sigma, and I'll get to that in a moment. But the rule is that it's found by taking the square root of the sum of the average squared difference of each value from the mean. So what does that mean? That is to say that if we take the square root here of this whole term, and what is this whole term? Well, this I told you we'd get back to is the sum. This is just saying the sum of all of these things right here. And this little subscript I is just counting each one of the terms or datum that are involved in the set. So, for example, let's say we had, actually we'll get to an example in below, so we'll talk about that later on. After you sum up all of those differences from the mean, and we all know how to calculate the mean by now, you square each of those and divide by the total number n in the set. And n is just the number that we had in the set. So if there was 10, you divide by 10. If there was 10,000 datum, you divide by 10,000. Whatever it was that was in the datum, or the total datum set. Whatever it was for the total set, you divide by that number. Let's move down a little bit here. So did you know that 95% of all the data of a set is contained within two standard deviations of the mean or expected value? So what does that mean? Well, if we look at a picture here, this basically is just showing a very, very broad segment of data, which shows that here in the middle you have what would be the mean, or that average value of your data, and then all of these are these 2 points here are just one standard deviation away from that mean value in the middle. So that these percentages are saying that 34.1% of all the data will be encompassed within that first standard deviation. That's why we have this big blob right here. This is just, these highlighted areas is technically the area under the curve. We don't need to know that either, but that's where that comes from. That's where this whole little segment comes from. And then two standard deviations away is another 13.6% added on to that on each side of the curve. So on each side of your data, you're adding another 13.6%. So 13.6 plus 13.6 plus 34.1 plus 34.1 adds up to 95%. So 95% of all the data would be found between those two standard deviations. So let's just discuss where standard deviation comes from. So variance is the measure of dispersion that is found by determining the sum of the average squared difference of each value from the mean. Well, that sounds familiar, ironically enough, because it is. All this term here is comparison to what we had up here is it's just, this isn't square rooted. So both sides of this term are still squared. So variance is just sigma squared. So thus the standard deviation is the square root of the variance. Informally, so less math terms here, it measures how far a set of random numbers, typically random, are spread out from their average value or the mean or the expected value. All the same term there. Mean, expected value, the average value, all that fun stuff. Same kind of thing. So if we wanted to calculate the standard deviation, I'm hoping I can, perfect, using the piece of paper, find the standard deviation of a set A. A is just a random set of numbers in this case. A could be anything. But here we have the numbers 1, 3, 7, 12, 18, and 19, conveniently already placed in order for us. So how many numbers are there? There's 6. You can count those ourselves. So 1, 2, 3, 4, 5, 6. So first we need to calculate the mean, because in order to use our formula that we had up here, should have wrote that down below, we need the mean in order to subtract each one of those individual values from this number. So it's coming back down here. First we calculate the mean and then divide by 6. So we add up all the numbers, divide by 6. So 1 plus 3 is 4. 4 plus 7 is 11. 11 plus 12 is 23. 23 plus 18 is 41. And then 41 plus 19 is 60. So 60 divided by 6, 10. So our mean is 10. Wonderful. So you'll see here in this giant little square root symbol that the 10, that mean, is being subtracted from each one of those terms and then being squared, just like we saw up here. Just like we saw up here. So this sum here, this little circle I'm circling right now, when we jump back down here, is what's happening each and every time here. This is the sum. See these plus signs in between these? That's the sum of each one of those differences from the mean. So you subtract the mean from each one of the data points. You'll see 1 subtract 10 squared, 3 subtract 10 squared, 7 subtract 10 squared, etc. Then we divide by the number that was in the set. We know that was already 6. Divide that by 6 and take the square root of that whole thing. So 81 plus 49 plus 9 plus 6 plus 64 plus 81, all divided by 6 is 48. So approximately 6.93 is the standard deviation.